this morning, we're going to start by This morning we're going to start by discussing the contributors to science. If you wouldn't mind opening up your Buzz and going to the activity for the blog unit 1. And let me know when you get there. So it's going to look like fun. Right here, this blog unit 1.
All right, miss, I'm there.
All right, has everyone gotten there?
I have, miss.
Oh, I forgot I muted mine. Dang it. How's that gonna work? Okay, hold on just a second. Okay, Stephen, did you get the blog unit opened up?
Yes, ma'am.
Okay, there we go. Now I can hear you. All right, that's gonna work. Okie dokie. So, Baylor, are you on the blog post? Yes? Okay, so let's talk about some people from the past. We're going to talk about the 1500s. I believe we can find that in our history session. Maybe. So if we come back up here to lesson 2, the history and future of biology, and we go to this slideshow. Right here. This is going to give us some of those people. scientist and tell about what he contributed. So today in class, we're going to learn about the units of measurement. I'm hoping that none of this is brand new to you. You should have been learning this all throughout school. So we're going to do a brief overview.
Like in elementary and middle school, or
Probably more middle school, like your 7th, 6th, 7th, 8th grade science class.
For a minute there, I thought you meant like elementary and middle school, because for elementary, I didn't. No.
Well, I wouldn't expect you to remember things way back in elementary school.
Yeah, like for the before in Austin, I went to STS for 3rd, 4th, and 5th grade. The reason why I transferred there was pre-K kindergarten, second grade through 5th grade STS, pre-K kindergarten, 1st grade Belmar. It was not a good school for me.
All right, let's get back to units of measurement. So what is a unit? If I were to tell you I walked 5, does that really tell you anything?
No.
Well, what did I walk? I walked 5 steps. I walked 5 miles. I walked 5
Feet.
dogs. So the unit is important to tell you what the number means. Okay, so in science, it is so important that when you are writing your math equations, when you're writing numbers, you always, always, always include the unit. In fact, it is wrong if you do not include the unit. So for length, the unit that we use is meter. We use the meter for length. Volume, we can use the cubic meter, the liter, or the milliliter. These are all cubic. Sorry, they're not cubic. The cubic meter, or the liter and the milliliter. For mass, we use the gram. And temperature, the official SI unit for temperature the official SI unit for temperature is Kelvin. However, the majority of scientists and countries other than the United States uses Celsius. Now, scientists are going to almost always use the International System of Units. The SI units are also used in many countries around the world by many people. So it's not just for scientists. Some vocabulary that we need to become familiar with this unit or for these lessons is going to be area, which is the measurement that describes the amount of space the surface of an object occupies. You can find area by multiplying the length times the width. These are good. That is good for a square and a rectangle. The formula for circle is pi r squared, where pi is 3.14 and r squared is the radius squared. For a triangle, you can take half of the base and multiply it by the height. Okay, so the cubic meter is going to be the base unit of measurement for volume. Kelvin is the unit for measuring temperature. Kilogram, base unit of measurement for mass or weight of an object. The mass is the amount of matter an object has. Now keep that one in mind, because when we talk about weight, we're not talking about the amount of matter, we're talking about the mass times the gravity, okay? So weight is dependent on gravity where mass is not. The meter is going to be the base unit of measurement for length. Temperature is a measure of the heat energy of an object. Volume is the amount of space an object takes up, okay? So now let's go back to volume. It also has a formula. You can find the volume by multiplying the length times width times height of regularly shaped objects. If you have an irregular shaped object, you can measure its volume by the displacement of water. So you can take, say, a rock, you can fill up a graduated cylinder, write down the volume, place that rock inside the graduated cylinder, and then write down the new volume, subtract the two, and that's the volume of the rock. Conversion. Conversion is going to be to change from one form to another, and then dimensional analysis is going to be the method that we use to convert things from one unit to another. So the metric system, it's based on powers of 10. In the metric system, meters, liters, and grams represents 10 to the 0 power, or a measurement of 1. These units then get multiplied by powers of 10 to represent larger or smaller measurements. Okay, so you have your base unit, which is going to be meter, grams, or liters right here. And you're going to multiply that by 10 to get to decameter. Okay, we're just going to say meters. We're going to multiply it by 10. We're going to get to decameter. So this says that for every meter, that there are 10 meters in every decameter. Okay, for hectometer, you would multiply it by 10 to the second power, or 100. So now you're saying that for every hecameter, there are 100 meters. Same for kilo. So a kilometer, there's 1,000 meters in 1 kilometer. Now, if we go the opposite way, we're going to be multiplying by the negative power. So we say there are 0.1 meter in 1 decimeter. Or you could say there are 10 decimeters in 1 meter. There are 100 centimeters in 1 meter. Or you could say that there is 0.01 meter in a centimeter. And so on and so forth. So you just multiply by the power of 10. One way to remember this is King Henry died drinking chocolate milk. So the metric system, this is kind of just another way to explain it. And to familiarize yourself with these measurements, you could say that a meter is approximately equal to the length of a yardstick. A liter is about the same as a quart. And a gram is approximately the weight of a paperclip. So how big, now we're going to watch a little video. How big is a meter? The size of an average, what was that, 10th grader?
Yeah.
How big is a millimeter? A dime is about the width of a dime. While a grain of sand can be about 0.1 millimeters. So now we're going to get into the invisible. How big is a micrometer? A decimite is about 400 micrometers. The compound light microscope can help you see things that are just a few micrometers in length. But a virus can only be seen with an electron microscope because it is so small. Okay, so these are some conversion factors. I've also written them up on the board. 1 inch is the same as 2.54 centimeters. A yard is 0.91 meters. A mile is 1.61 kilometers. An ounce is 28.35 grams. 1 pound is 0.45 kilograms, and so forth. Okay, so now we're going to go to the whiteboard. Stephen, can you pull the whiteboard up big enough for you to be able to see it? Can you click on it maybe? Excuse me. Okay, hopefully you will be able to. Stephen, will you tell me, did that change it to where you're just seeing the whiteboard now? Or did that only change it on my side? That only changed it on my side. Okay, well, I am going to move forward. Okay, Baylor, I'm going to have you work alongside with me. Stephen, if you'll get some paper and work with me as we do these problems. Okay, so first we're going to convert from, or within the metric system. So let's find out how many meters are in 7.8 kilometers.
What are you open?
9.
9? Okay. Oh, English.
Please go.
Are you opening for 2? Okay.
So how many meters are in 7.8 kilometers? Okay, well, according to our chart, we have our base is 1. Deca was 10. Hecto, 100. Kilo, 1,000. And mega was a lot bigger. And then deci is 0.1. Centi, 0.01. Milli, 0.01. And then micro was really, really small. Okay, so when we're going from kilo to meter, we are going to multiply. So there are 1,000 meters in 1 kilo. All right, so we start with 7.8 kilometers. And we want to get rid of kilometers. And we look up here. So 1 kilo is 1,000 meters. So we put 1 kilo on the bottom. And we put 1,000 meters on the top. Okay. Now you can see these are on opposite sides. So we can cancel out our kilometers and we're left in meters, which is what we were looking for. So we can stop here and we're going to take the 7.8 and multiply it by 1,000. So this is going to equal 7,800 meters. Okay. Yeah. Oh, yeah. Wet wipe will work. Perfect. Okay, so let's do another one of those. 9.
I'm going to change my schedule around. I
Okay.
apologize.
No problem.
Taylor, when you get that? Are you thinking? Very well.
So let's try to find out how many deciliters equal 5 liters. Okay, so deciliter is smaller. Okay, so we start with our 5 liters, and we want to know how many deciliters. So we're going to put liters on the bottom, and we know that there's 0.1 liter in 1 deciliter. Okay, so there's 0.01 liters in 1 deciliter. Our liters are on opposite sides, so we can cancel them out, and we're left in deciliter, which is what we were looking for. So this time, instead of multiplying, we're dividing. So we take 5 and divide it by 0.1. Let me get out of that. Yes, give me 2 seconds. Yes. See, mine was doing that too. Okay, so whenever you have a number side by side, you multiply. And then if it's on the bottom or top, you divide. So you take 5 times 1 equals 5, and you're going to divide it by 0.1. And that's going to give you 50 deciliters. So this here is dimensional analysis. This is the method of converting from one form to another. Okay? Well, now what happens when they tell you, actually, I want to know how many kilograms is a 145-pound person? Okay, so now we're going from pounds to kilograms. We can't just look at our metric chart because we're going from 2 different types of measuring systems. Well, that's where your conversion factors come into play. Okay, so we want kilograms from pounds. So we're starting with 145 pounds. And we're going to look for a conversion factor that goes from pounds to kilograms. Can you find any up on the board? We're looking for pounds to kilograms. Stephen, are you keeping up? Are you staying with us?
I'm trying, miss. I'm gonna do this. I still haven't done the blogging. It won't let me write on it.
Okay, that's all right. Are you just staying with us at least?
Yeah, I was just trying to watch it.
Okay. I'm also
But-
recording this, and I'll post it on our thing so that if you want to go back and watch, you can.
Okay.
On our classroom. I'll post it in the classroom.
Okay.
But I want you to have some paper and kind of following along if you can. All right, so our conversion factor from pounds to kilograms, you can see it right here. 1 pound equals 0.45 kilograms. Okay, so now we have to decide how we're going to set that ratio into our dimensional analysis chart. Okay, so I'm starting in pounds and I want to end in kilograms. So the first thing I'm going to do is I'm going to find my pounds factor, which is 1 pound, and I'm going to put it on the opposite side so that it cancels. So 1 pound. All right, so now that is canceled, equals 0.45 kilograms. That's going to go up here on the top. 0.45 kilograms here on the top. Okay, now I'm going to multiply everything on the top together. So 145 times 0.45. That's going to give me 65.25 kilograms, because that's what I was left in. And then I'm going to multiply everything on the bottom, which is just 1. Anything divided by 1 is going to be whatever it was, so I don't actually have to divide anything here. And this is my answer. Okay? And it was asking me for kilograms. I used my conversion factor to get rid of the pounds, and I'm left in kilograms. So this tells me that a 145-pound woman will weigh the same as 65.25 kilograms. Okay? Is this making sense? Are you understanding how to do it?
And it's getting there.
Getting there? Okay. All right, let's do a few more. Okay, so now we want to know how many. Okay, here's a good one because it's going to be a multi-step one. Okay, how many grams? We're looking for grams are in 2 pounds. Okay, so we're going to look for that conversion factor again. We're looking for grams and pounds. The only thing that I have is pounds and kilograms. So we're going to start there. We're starting with the 2 pounds. Okay, we're going to use our conversion factor. We're getting rid of pounds, so we're going to put the 1 pound on the bottom. And we'll put our 0.45 kilograms on the top. Okay, so now we are done with pounds and we're in kilograms. Is that what we're looking for? Are we looking for kilograms? Nope, we're looking for grams. So we can actually keep going. We don't have to do any math yet. We can just add another T to our chart. And we want to get rid of kilograms. So now we're going to look up here. Kilograms. For 1 kilogram is 1,000 grams. Okay? So I'm going to put my 1 kilogram here on the bottom because I want to cancel out kilogram. And I'm putting 1,000 grams on the top. All right, now I'm left in grams. Is that where I want to be? Grams is, yes, where we want to be. So now we're going to stop. And we're going to multiply everything on the top. So we're going to say 2 times 0.45 times 1,000. Okay? And I got 900 grams. And then you multiply everything on the bottom, but in this case, it's just ones. So 1 times 1 is 1. 900 divided by 1 is 900. So we are good here. So there's our answer. There are 900 grams in 2 pounds. Got it?
Yes.
All right, so the beauty of dimensional analysis and the T-chart is that you can just keep on going until you get where you need to be, okay? And you don't do any math till the very end. Okay, so let's find how many centimeters are in 6.9 kilometers. Okay, so we're staying in the metric system, but we're going from below base to above base. So I always like to break this one into 2 parts. So we start with 6.9 kilometers. Sorry, we go from above base to below. So we're going to take this kilometer and we're going to put it into the base mode. So we're going to take it to meters. So we know that 1 kilometer, we're going to put that on the bottom to cancel it out, okay, is the same as 1,000 meters. Okay, and that's what this chart tells me. 1 is the same as that, okay? So 1 kilometer has 1,000 meters. Now we don't want meters, we want centimeters, so we're going to keep on going. Centimeters tells me that 1 centimeter has 0.01 meter in 1 centimeter. Okay, so now my meters is canceled and I'm left in centimeters. Do you see where I got all those numbers? Not quite?
Not quite.
Okay, so my kilometer, so this is my metric chart, right? For 1 kilometer, there's 1,000 meters, or base. For 1 kilobase, this guy, there's 1,000 base. And your base can be a meter, a gram, a liter, okay? Meter, gram, liter. Okay? So for 1 kilo, meter, gram, or liter, there are 1,000 meter, gram, or liter. Okay? So this is your conversion chart for metric system. So that's where I'm getting these numbers. So when it says kilometer, and I want a centimeter, so I'm going from kilometer all the way down here to centimeter. Okay, so instead of just jumping from this one to this one, I'm breaking it into 2 steps. I'm going from kilometer to meter. And then I'm going to go from meter to centimeter. Okay, so in 1 kilometer, there's 1,000 meters. I put kilometer on the bottom to get rid of it. And now I'm left in meters, but I want centimeters. So I have to put my meter on the bottom here. And for 1 centimeter is 0.01 meters. Okay, so 0.01 meters here, 1 centimeter here. Okay, so now whenever I enter this into the calculator, I'm going to multiply everything on the top. So 6.9 times 1,000 times 1. So I have 6,900. And then I'm going to take everything on the bottom. So 1 times 0.01, which is 0.01. And now I'm going to divide. So I'll take 6,900 and divide it by 0.01.
Oh, 1 divided by 0.0.
So the 1 is going to be multiplied. So down here, 1 times 0.01, which gives you 0.01. And then you take the 6,900 and you divide it by the 0.01. So you take the top number, divide it by the bottom number. That'll give you your answer. So there are 690,000 centimeters in 6.9 kilometers. Okay, are you starting to get it? Getting there?
Yeah.
It takes a lot of practice, I'll tell you that. Which is good because this whole lesson 8 is nothing but practice. Okay, so now let's move on to the next one. It wants to know how many centimeters are in 32 inches. Okay, so if you're going from centimeter or from inches to centimeters, can we use this chart over here? Inches.
Yes.
No, because it's two different systems of measure. So meters and inches. So you have the metric system and you have the United States system. Oh, it's called something else, but now I can't remember. Empirical system? Anyway. Okay, so what we're going to do is we're going to look for a conversion factor. In this case, we're looking for inch and centimeter. So do you see any up here that deal with inches and centimeters?
I see the first one.
The very first one, you are right. So our conversion factor is the first thing I'm going to write down. So I'm going to put CF equals 1 inch equals 2.54 centimeters. Okay. So now we want to go from inches to centimeters, right? So what is the first thing that I need to do? What is my first step? Sorry, probably not the first step. So the first step is to find my conversion factor, okay? So the second step would be to create my dimensional analysis chart, right? So I'm going to create my chart. Now, what do I plug into my chart? What number goes very first?
I want to say 2.54.
You're really, really close. The first number that we want to put in there is our given. So our given and then our conversion factor goes right beside our given, okay? So step 2, we create our T-chart and we fill in with our given, which was 32 inches. And then we put in our conversion factor. So when we're trying to convert from inches to centimeters, what number goes on the bottom? Would it be the one with inches or the one with centimeters? So I'm talking about right here. Because we want to get rid of inches, what do we put here to cancel inches out? Do you remember?
No.
Okay, so our conversion factor on the bottom has to be the same unit. Can't spell. Okay, so step 3. Determine which unit goes on the bottom. The bottom number has to have the unit that matches the given. Okay, so does that make sense? So your given is in inches. Your bottom number has to have the unit that matches your given. So which number matches the units from the given? So what units are you in? Inches? Okay. So for the bottom number, it has to match the same unit. Okay, so the conversion factor is 1 inch equals 2.54 centimeters. So which of these numbers matches your given? Which unit matches? Sorry, not number.
I want to say inches.
Inches matches. And there's 1 inch. So we're going to write our 1 inch here. So now what number goes beside? What number goes here? It's going to be the other number. So we put 1 inch here. So the other number goes here. 2.54 centimeters. So step 4, the top number has to be the other part of the conversion factor. Okay, so our conversion factor said 1 inch equals 2.54 centimeters. So first we wrote down our given, and then we put the matching unit in the bottom, which in this case was 1. And then the top number has to be the other part of the conversion factor. So that's going to be your 2.54 centimeters. Does that make more sense? Getting there?
Yeah.
Okay, so bottom number matches the given. See how these match? 1 inch, 30 or inches match. Top number has to be your other part of your conversion factor, which is centimeters. And what are we looking for? We're looking for centimeters, correct? Do we have centimeters here?
Yes.
Okay, so since centimeters is here, we can stop there. And what you do is you multiply the top numbers together. So 32 times 2.54 is 81.28. And since our inches canceled and we're left in centimeters, it's going to be centimeters. So you can say that there are 32 inches in 81.28 centimeters. Okay, so now we're going to deal with an area problem. So this one gets a little trickier. Okay, so you have a room that is 16 feet by 13 feet, and you want to know the area. Okay, well, area is length times width, but we want to know the area in meters squared. Okay, we're given feet, but we want meters as our final answer. Okay, so we're looking for meters. Is there a conversion factor that goes from feet to meters? I actually don't see one up on the board. So what you can do is you can look that up. So 1 foot equals 0.3048 meters. Okay, so the first thing you do is you convert each of these into meters, okay, before we plug it into our equation. So we're going to do step 1, find the conversion factor, which was here, okay. Okay, conversion factor. We write down our given. All right, so our first given is 16 feet. And what has to go here? The bottom number has to have the unit that matches the given. So which number, is it 1 or is it 0.3048? Which number matches? Go.
Wait,
I keep saying number. Which unit matches? Okay, which number has the matching unit to 16 feet?
1 feet?
1 feet, correct. So the bottom number has to have the matching unit as the given. Now the top number has to be the other part of the conversion factor. So this was one part of the conversion factor. This is the other. Okay, so the top number is the other part. So 0.3048 meters. Okay, we need to be in meters squared, so we can stop here because we have a meter there. So 16 times 0.3048. So this one is 4.8768 meters. Okay, now this is where this problem is a little tricky because we actually have two numbers that we have to do this to. So 13 feet, we're going to do the exact same thing because it's in feet. So we're going to put the 1 foot on the bottom, 0.3048 meters on the top. We're going to plug that in. And that one is 3.9624 meters. Okay, so now both of our numbers here are in meters. We can plug it into the formula now. So you have 4.9 meters times 3.96 meters. And your answer to what is the area is 19.4 meters squared. So when you're doing math problems, when you're trying to find the area or the volume, the number one thing you must look for are units. So if you're given feet, you have to convert to meters. You can convert to meters by finding a conversion factor and then plugging in your numbers that way. But once all of your numbers have the correct units, then you can plug it into the equation for area. All right. If you would I'm going to put a review on our Google Classroom for this with more practice problems. And as you go through them, if you get stuck, you're more than welcome to come in and ask for help. You can get help with your with the aides, with your other teachers. So I want you to practice these, but I'm open to help as well. Okay?
All right.
And our class is now over. If you'll make sure that you get lessons 7 and 8 completed, and then quiz 2 as well. All right, before next class period, which will be Tuesday. Okay.
All right. See you later, miss.
Bye, Steven. Thanks for joining.
Thanks for letting me join.
You're welcome. I enjoyed having you in class today, Baylor.
Same.
Please do not hesitate to come in for help if you need it. Ask, okay?
Okay.
And if you'll look on the Google Classroom, I'll have that review posted by the end of today for the quiz, okay?